This entire CH3 group is bonded to the carbon immediately preceding it in the condensed formula. Hey there, OChem Ninjas. In this video, we're going to look at the common conventions for condensed structures in organic chemistry. Organic chemistry as a field has been around since the 1800s. Drawing a molecule on paper with a pen is easy enough to do, and we have computer software that will render this very easily. But for the early chemist, drawing a structure like this in a book or a journal article would have been very hard to do. There are actually stencil sets that you can buy that are organic chemistry stencil sets that have bond angles and rings and all sorts of things, but out of all of this, the condensed formula was born. The condensed formula is primarily a way to show a very complicated molecule in a way that will be amenable for typing on a typewriter. Over time, we have adopted conventions to allow us to translate between molecular structures and the condensed formula on paper. And while we rarely use a condensed formula for an entire molecular formula like this, we still need to know the rules because we still see them from time to time, and we often see them incorporated with other structure drawing motifs, such as the line angle structure. It is not uncommon to have a line angle structure where part of it is written as a condensed formula. So we're going to work our way through this molecule, going from simple to more complex, and we're going to reveal the condensed formula conventions that you need to know for organic chemistry. Let's get started. The first convention says that we write the carbon first. We write the letter C for carbon, and then after the C, we write all of the things that are bonded to that carbon. Anytime we see bonding groups in organic chemistry condensed formulas, they are always bonded to the carbon immediately preceding it in the condensed formula. So for this condensed formula, if we start with carbon 1, we would first write the carbon for carbon number 1, and then carbon number 1 is bonded to 3 hydrogens, so we would write CH3. These would be the 3 hydrogens bonded to carbon number 1. Same thing with carbon number 2. We would start with the carbon, and then we would write CH2 for those 2 hydrogens are bonded to the carbon immediately preceding it in the condensed formula. For carbon 3, there's a bromine attached to that carbon. No difference. We start with the carbon, and then we list things attached to that carbon. By convention, we list the hydrogen first, and then the bromine. The hydrogen and the bromine are both bonded to the carbon immediately preceding it in the condensed formula. The next convention tells us what to do when we have a polyatomic group bonded to the backbone. When we have a polyatomic substituent on the molecule, we bracket that entire group in parentheses. So with carbon 4, we would write the carbon for carbon 4, and then the hydrogen. And then for the CH3 group attached, we would put that CH3 group in parentheses. This entire CH3 group is bonded to the carbon immediately preceding it in the condensed formula. Similarly, for carbon number 5, we start with the carbon and the hydrogen bonded to it. The OH group goes in parentheses. That OH group is bonded to carbon 5, immediately preceding it in the condensed formula. The next convention is about saving space in condensed formula. This condensed formula is already getting pretty long. Actually, a little bit nervous about how much room I'm going to have at the end. So the next condensed formula convention tells us how to save a little bit of space when we're writing the condensed formula. If we have repeating groups in the molecule, we can combine those groups in parentheses to show that they are repeating in the molecule. For example, carbon 6 and 7 are identical. They're consecutive CH2 groups. So after this OH group, we can, in parentheses, put this CH2 group twice. We can say that there are 2 additional CH2 groups coming up next in the condensed formula backbone. We can also use this convention when we have 2 identical groups attached to the same carbon. So on carbon number 8, we have carbon and then 2 NH2 groups attached. So in parentheses, we can write NH2 twice. There are 2 NH2 groups bonded to that preceding carbon. One caveat for condensed formula is they don't work really well for ringed structures. Since we're trying to type this on a typewriter, if this carbon bonded back over to this carbon, it would be hard to show that in a typewriter format. So we can't really write a condensed formula for a cyclic structure, with the exception of benzene. Benzene is a common substructure in organic chemistry, and so we have a way to treat that in condensed formula. In real life, this should go on in a linear form forever. Since I'm running out of space a little bit, I'm going to carry on to the next line, but just keep in mind this should all be consecutive. We have a carbon 9 spacer, so we have a CH2 group at carbon 9. On carbon 10, we have the hydrogen attached to carbon 10, and then we also have the benzene. The way that we can write the benzene is as C6H5. C6H5 is a substructure in the condensed formula that stands for the benzene ring. Since benzene ring is so common and ubiquitous, we can say C6H5 is our shorthand condensed formula for a benzene ring. So when I see C6H5 in a condensed formula, I know that this is a benzene ring attached to the carbon immediately preceding it in the condensed formula. The final convention that I'm going to talk about today has to do with carbonyls. Carbonyls you want to be a little bit careful with in your condensed formula. After a CH2 spacer for carbon number 11, we have carbon number 12, which has the carbonyl attached. Different chemists sometimes do different things for carbonyls. Sometimes chemists will just write an oxygen and then they'll move on with the rest of the condensed formula. I don't really care for this way because this makes it look like the oxygen is in the linear backbone of the molecule, almost like an ether functional group, but it's not. So what I would recommend for carbonyls is to put the oxygen in parentheses, a single atom in parentheses. That lets the reader know, just like other parentheses, that this oxygen should be bonded off of carbon number 12 and not part of the condensed formula backbone. But not every chemist does it this way, so you need to be aware when you have oxygens in the molecule, pay special attention, see if it's a carbonyl or an ether. I have a separate video that I'll link to down below that goes through condensed formula examples in varying degrees of difficulty, and one of those degrees of difficulty is this exact example of an ether versus a carbonyl. So you should watch that video to see more examples of this phenomenon. Let's go ahead and finish out the rest of the molecule. We have carbon number 13, and it has CH3 groups attached. But how many CH3 groups does it have attached to it? Yes, there's the one above and the one below, but notice there's also another identical CH3 group in carbon number 14. So the way that we can combine all of these together is by writing carbon 13, and then in parentheses, the CH3 3 times attached to carbon number 13. That encompasses the CH3 on top, the CH3 on bottom, and carbon 14 on the right. The other area where you need to be careful with carbonyls is with carboxylic acid derivatives. Carboxylic acids and their derivatives are historically confusing for students in condensed formula, particularly when going from the condensed formula back to the structure. So if we look at this molecule, we start with carbon number 1 and its 3 hydrogens, and then carbon number 2 and its 2 hydrogens, and then we have carbon number 3. Carbon number 3 is doubly bonded to one oxygen and singly bonded to another. The convention we use for carboxylic acid derivatives, such as this, is we write carbon, oxygen, oxygen. This convention tells us everything we need to know about the carboxylic acid derivative. You want to be on the lookout for this convention in your condensed formulas. There are certainly other ways you could imagine writing out a carboxylic acid derivative, but this is the convention that we have settled on. So what this convention tells us is that by definition, the carbon is doubly bonded to the first heteroatom and singly bonded to the second heteroatom. This is how we read this type of condensed formula notation and go back to an original structure. This tells us that carbon number 3 is doubly bonded to an oxygen and singly bonded to another different oxygen. We do it this way because the second heteroatom is in the carbon backbone of the molecule, so we can continue straight on with the rest of the backbone after the second heteroatom. After this oxygen, we can continue with carbon 5 CH2 group and carbon 6 CH2 group. Before, we could have combined those into one CH2 group in parentheses. That is not strictly required, and here I'm doing it to space it out a little bit from the next carbonyl that we're going to talk about. One last thing to mention about this way of drawing esters in condensed formula is we do have 2 repeating oxygens. So I'll go ahead and warn you that sometimes you will see this written as the CH3, CH2, and then CO2, followed by the rest of the condensed formula. If you see that, don't get confused. It's the same thing. Carbon with 2 oxygens. We're still, by convention, doubly bonded to the first heteroatom and singly bonded to the second heteroatom. Both heteroatoms just happen to be oxygen in this case. Carbon number 7 is another carboxylic acid derivative, and we will treat this the same way. We will write the carbon for carbon number 7, and then we'll follow our convention. It's doubly bonded to an oxygen, so the first heteroatom that we'll write is the oxygen, because by convention, this carbon is doubly bonded to the first heteroatom. And then we'll write the nitrogen, because by convention, the carbon is singly bonded to the second heteroatom. The nitrogen is in the chain, so we can continue on with the rest of the condensed formula. We have the hydrogen attached to the nitrogen, followed by carbon number 9, the last CH3 group in the molecule. With these condensed formula conventions under your belt, you're on your way to being a true OChem Ninja.
Thanks for training with us today, Ninjas. Check out this other content to see if you can level up even further. As always, don't forget to like and subscribe.